Hello, friends. Did you know there's one major reason why humanity has struggled to explore Mercury? Can you guess what it is? Think about this for a moment. We've sent more than **30 missions to Mars. We've launched over **20 missions to Venus. We've even explored Pluto, one of the most distant worlds in our solar system. On top of that, 2 spacecraft have already traveled beyond our solar system into interstellar space. But what about Mercury, the planet closest to Earth after Venus in terms of average proximity? How many successful missions have we sent there? The answer might surprise you. The story begins on November 3, 1973. NASA was preparing to launch Mariner 10 *, the first spacecraft ever designed to visit Mercury. Scientists were excited, but they were also nervous. No spacecraft had ever attempted such a mission before. Many wondered whether it would even reach Mercury. Mariner 10 wasn't just another space probe. It was the first spacecraft that planned to use a revolutionary technique called gravity assist. Instead of carrying enormous amounts of fuel, it would use the gravity of another planet to change its speed and direction. This approach had never been tested on such a mission. Fortunately, the launch was successful. Mariner 10 completed its long journey through space and became the first spacecraft to fly past Mercury. At first, everything seemed to be going exactly as planned. Scientists celebrated the historic achievement. But the celebration didn't last long. During its final flyby, the spacecraft encountered serious problems. After running low on fuel, Mariner 10 could no longer control its trajectory. Eventually, it crashed into Mercury at a speed several times faster than the speed of sound. Its mission came to an end. Although the spacecraft successfully transmitted valuable data back to Earth, many people still consider the mission only a partial success. Why? Because Mariner 10 managed to photograph only a small portion of Mercury's surface. Most planetary missions capture tens of thousands of images. Mariner 10 returned only about *2,700 photographs and some of those were actually images of Venus taken earlier in the mission. As the spacecraft approached Mercury, it encountered challenges unlike those faced by missions to any other planet. Extreme heat from the sun. Intense solar radiation. Powerful gravitational forces. And Mercury's own harsh environment. These problems made the mission incredibly difficult. In fact, they remained a challenge until the spacecraft finally exhausted its fuel. This raises an important question. Why is Mercury so incredibly difficult to explore when it's one of the closest planets to Earth? The answer lies in the extreme environment surrounding the smallest planet in our solar system. So, what exactly makes Mercury one of the most difficult planets to explore? The answer lies in 3 major challenges. The Sun's extreme gravity. Its intense heat and radiation. And Mercury's own gravitational pull. Let's begin with gravity. Any spacecraft traveling to Mercury is constantly being pulled by 2 different objects. One is the Sun. The other is Mercury itself. Now think about it. Which of these has the stronger gravitational pull? Obviously, the Sun. Its gravity is so powerful that a spacecraft naturally wants to fall toward it instead of entering Mercury's orbit. This is one of the biggest obstacles in every Mercury mission. Fortunately, scientists developed a clever solution. Speed. A spacecraft heading toward Mercury cannot simply fly straight at the planet. Its speed must be calculated with extraordinary precision. If it approaches at exactly the right velocity, it can fly past Mercury while resisting the Sun's overwhelming gravitational pull. But there's a catch. Imagine driving a race car around a sharp curve. If you're moving too fast, you'll lose control and fly off the road. If you're moving too slowly, you'll never complete the turn properly. The same principle applies to spacecraft. To place a probe into Mercury's curved orbit, its speed has to be reduced at precisely the right moment. If the spacecraft slows down too much, the gravity of the Sun, or even Mercury itself, can pull it inward, causing it to crash. If it remains too fast, it simply flies past Mercury without entering orbit or collecting enough scientific data. Finding the perfect balance is incredibly difficult. And this is exactly what made the Mariner 10 mission so challenging. During its final encounter with Mercury, intense solar radiation affected the spacecraft's trajectory. Its path changed slightly. That small change was enough to bring it deeper into Mercury's gravitational influence. Once that happened, the spacecraft could no longer escape. Mercury's gravity pulled it closer and closer until it finally crashed into the planet's surface. This wasn't a gentle landing. The impact occurred at an incredible speed, several times faster than the speed of sound. The collision released an enormous amount of energy. Scientists estimate that if such an impact had occurred on Earth, it would have been powerful enough to cause catastrophic destruction over a large area. Despite the crash, Mariner 10 changed space exploration forever. It proved that reaching Mercury was possible. But it also revealed just how difficult future missions would be. Every mission to Mercury must survive extreme temperatures, intense solar radiation, and one of the most complex gravitational environments in our solar system. And that's only the beginning. Mercury itself has some of the strangest characteristics of any planet we've ever discovered. Now you might be wondering, if Mercury is so difficult to explore, why are scientists still so eager to study it? The answer is simple. Mercury behaves unlike any other planet in our solar system. In fact, if you stood on its surface, you would witness one of the strangest sights in the universe. On certain parts of Mercury, the Sun appears to rise, stop, move backward, and then rise again before continuing across the sky. Imagine watching two sunrises in a single day. It sounds impossible, but on Mercury, it really happens. Even more astonishing is the length of a day. One full solar day on Mercury lasts 176 Earth days. That means if you celebrated your birthday there, the Sun wouldn't return to the same position in the sky for almost 6 months on Earth. But here's the truly fascinating part. A single year on Mercury lasts only 88 Earth days. In other words, Mercury completes 2 entire orbits around the Sun before one full day has passed. How is that even possible? The answer lies in Mercury's unusual motion. Mercury rotates very slowly on its axis. At the same time, it races around the Sun faster than any other planet in the solar system. This unique combination creates an extraordinary day-night cycle. For nearly half of its orbit, the same side of Mercury remains under blazing sunlight. Then, for the next half, it is plunged into complete darkness. As a result, one Mercury day is equal to 2 Mercury years. This strange behavior is caused largely by the Sun's enormous gravitational influence. Mercury is the closest planet to the Sun. Because of this, the Sun's gravity constantly pulls on the planet, slowing its rotation over billions of years through a process known as tidal forces. A similar phenomenon occurs much closer to home. Our Moon always shows the same face to Earth because Earth's gravity has synchronized its rotation. This is called tidal locking. Mercury isn't fully tidally locked like the Moon, but the Sun's gravity has dramatically slowed its spin, creating its unusual rotation pattern. At the same time, Mercury's revolution around the Sun is incredibly fast. Why? The answer goes back to the birth of our solar system over **4.5 billion years ago. As the giant cloud of gas and dust surrounding the young Sun collapsed, it began spinning faster and faster. Just like a figure skater spins faster when pulling in their arms, material closer to the center gained tremendous speed. Since Mercury formed closest to the Sun, it inherited that high orbital velocity. That's why it circles the Sun in just *88 Earth days. Mercury's unique orbit doesn't just make it fascinating. It also provides one of the best natural laboratories for testing Albert Einstein's general theory of relativity. Because Mercury travels through such an intense gravitational field, even tiny effects predicted by Einstein become measurable. Its orbit shifts ever so slightly over time, a phenomenon known as the precession of Mercury's orbit. For decades, scientists couldn't explain this mysterious motion using Newton's laws alone. Then Einstein's theory provided the answer. His equations predicted Mercury's orbital behavior with remarkable accuracy, making it one of the first major confirmations of general relativity. Even today, Mercury remains one of the most important planets for testing our understanding of gravity, space, and time. And that's exactly why scientists continue sending new missions to explore this extraordinary world. To answer these mysteries, scientists launched another ambitious mission in *2018. Its name is BepiColombo. This is one of the most advanced planetary missions ever built for Mercury. Unlike previous missions, BepiColombo is designed to do much more than simply take photographs. Its goal is to study Mercury's atmosphere, chemical composition, internal structure, geology, magnetic field, and evolutionary history. The spacecraft carries a wide range of sophisticated scientific instruments. One of its most important instruments is an ultra-sensitive accelerometer capable of detecting tiny changes in gravity. These measurements allow scientists to study how space-time behaves in the Sun's intense gravitational field. Because Mercury orbits so close to the Sun, it provides one of the best places in the solar system to test Einstein's general theory of relativity with even greater precision. Another major mystery involves Mercury's magnetic field. At first glance, it simply doesn't make sense. Mercury's metallic core makes up nearly *85% of the planet's total volume. For comparison, Earth's core accounts for only about *20% of its volume. You might expect Mercury to have a much stronger magnetic field than Earth. But the opposite is true. Mercury's magnetic field is only about *1% as strong as Earth's. Even more puzzling, the magnetic field isn't evenly distributed. It is noticeably stronger near Mercury's northern hemisphere than its southern hemisphere. Scientists still don't fully understand why this happens. BepiColombo is expected to provide crucial data that could finally solve this decades-old mystery. The mission may also help us understand how rocky planets formed during the early history of our solar system. But before BepiColombo, another spacecraft had already changed the future of space exploration forever. That spacecraft was Mariner 10. Although its mission ended with a crash, it achieved something revolutionary. It proved that spacecraft could travel through the solar system using gravity assists instead of relying only on fuel. A gravity assist works like a cosmic slingshot. Instead of firing powerful engines continuously, a spacecraft carefully flies around a planet. The planet's gravity changes the spacecraft's speed and direction. By following the correct trajectory, the spacecraft can gain enormous amounts of velocity while using very little fuel. Mariner 10 became the first mission to successfully use this technique by flying past Venus before heading toward Mercury. Today, gravity assists are one of the most important tools in planetary exploration. NASA's Voyager 1 and Voyager 2 used them to reach the outer planets before continuing into interstellar space. The New Horizons spacecraft also relied on a gravity assist from Jupiter to reach Pluto in record time. Without this technique, many of humanity's greatest space missions would never have been possible. Yet despite all these discoveries, Mercury continues to surprise scientists. It has an unusual orbit, an incredibly long day, extreme temperatures, a weak and mysterious magnetic field, and one of the most challenging environments any spacecraft has ever faced. Even after decades of exploration, many questions remain unanswered. Perhaps BepiColombo will finally reveal the secrets hidden beneath Mercury's scorched surface. Until then, Mercury remains one of the most mysterious and fascinating planets in our solar system. It reminds us that sometimes, the worlds closest to us can be the hardest to truly understand. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more documentaries about space, astronomy, and the greatest mysteries of our universe. Until next time, stay curious, keep learning, and keep exploring.